Welcome to this explainer. If you've ever stood on a beach and watched the water creep up the sand only to recede a few hours later, you've experienced one of the absolute most powerful natural phenomenon on Earth. Today, we're diving straight in and demystifying the invisible cosmic forces that are actually moving our oceans. It's a rhythm we can practically set our watches to, right? But what exactly is pushing and pulling millions of gallons of water around the globe every single day? To figure that out, we have to look way past the wind and the waves and uncover the massive planetary machinery at work behind the scenes. Here is our roadmap for today. We're going to cover the cosmic tug of war, how geography amplifies the tide, 3 daily tidal rhythms, when the sun joins in, and finally, extreme orbits, extreme tides. Let's start with section 1, the cosmic tug of war. Okay, so let's clear up a major misconception right out of the gate. People often confuse a chaotic, weather-driven ocean surge with a cosmically driven tide. Surges? They're totally chaotic, whipped up by extreme winds and sudden storm pressure. Tides, on the other hand, are incredibly regular and predictable because they're born not from Earth's unpredictable weather, but from gravity acting deep in space. Picture 3 invisible heavyweights locked in this massive cosmic tug-of-war. The moon's gravity does most of the heavy lifting here, pulling our oceans toward it, while the sun's gravity helps out to a lesser extent, but the real unsung hero in this fight is Earth's own spin. It creates a centrifugal force that acts as a vital, stabilizing counterbalance to all that inbound gravity. And because of this intense tug-of-war, Earth actually gets 2 major tidal bulges at the exact same time. It's wild. On the side facing the moon, lunar gravity wins out, pulling a massive bulge of water directly toward it. But on the exact opposite side of the planet, the moon's grip is much weaker. So Earth's spinning centrifugal force totally takes over, flinging water outward to create a second equal bulge pointing completely away from the moon. And here is a beautifully counterintuitive detail. Gravity isn't just yanking the water straight up into the sky off the Earth. The tide-generating force actually creates a net horizontal pull. It's essentially sliding the water sideways across the entire surface of the globe, gathering it all up into these immense ocean bulges. Moving right along to section 2, how geography amplifies the tide. The moon might set the stage, but Earth's physical terrain absolutely runs the show. When a tidal bulge rolls over a nice wide continental shelf, it grows way higher. When it hits a steep mid-ocean island, it stays relatively low. But when tides enter funnel-shaped bays or estuaries, man, those land masses act like giant acoustic amplifiers. They literally squeeze the incoming water and violently magnify its height and speed. To put that crazy amplification into perspective, we just have to look at Canada's Bay of Fundy. Thanks to its unique funnel shape, it boasts the absolute highest tides in the entire world. The water level there can rise up to 16 meters. Think about that. That is literally a 5-story building of water relentlessly rushing in over just a few hours. And this creates a completely relentless 24-hour cycle of extremes. High tide hits, and then boom, within just 6 hours, millions of tons of water pour rapidly out of the bay to hit low tide, only to immediately reverse course and do the whole shebang all over again. Twice a day, right like clockwork. That brings us to section 3 daily tidal rhythms. Now you might be thinking everywhere gets that same tidal schedule, but they totally don't. Most of the world experiences a semi-diurnal tide, which is your standard 2 highs and 2 lows of equal height every day. Other places get a diurnal tide, just 1 high and 1 low. But if you happen to live on the US West Coast or out on the Pacific Islands, you likely see mixed tides. That's where the water still rises and falls twice a day, but the heights vary wildly from one cycle to the next. Let's look at section 4, when the sun joins in. So the sun might be way, way further away from us, but its gravity heavily dictates the extreme heights of our tides. During a full or new moon, the sun, moon, and Earth form a perfectly straight line. Their gravity teams up, causing these massive spring tides. But just a week later, the sun and moon sit at right angles to each other. Suddenly, the sun is actively fighting the moon's pull, resulting in much, much smaller neap tides. But just to clarify who the real boss is in this relationship, the moon's gravitational grip on our oceans is actually more than double the strength of the sun's.
Sure, the sun is unimaginably huge, but in orbital mechanics, proximity is power. The moon is just close enough to easily dominate the battle over our water.
Finally, let's wrap up with Section 5, Extreme Orbits, Extreme Tides. Because orbits are ellipses and not perfect circles, distances in space are constantly changing, and that literally warps our oceans. When Earth swings closest to the sun, a point we call perihelion, which hits right around January 3rd, our tidal ranges get dramatically amplified. When we're farthest away at aphelion in July, the ranges shrink. And the moon plays the exact same game. It swings in close at perigee for extreme high and low tides and drifts out to apogee for a much calmer ocean.
Before we finish up, we really need to ground all these massive, mind-bending orbital mechanics back into the everyday kind of poetic terminology we use when we're actually standing on the beach: the ebb and the flow. When the water retreats from the high tide mark, that falling period is the ebb. And when the ocean reverses course, creeping back up the sand, that's the flow or the flood.
So, the next time you're out there watching the ebb and flow, just remember, it's not just water randomly sloshing around. It is the gravity of the moon, the pull of the sun, and the spin of the earth, all being funneled by the shape of our continents, acting out right at your feet. Every single crashing wave is a direct connection to the solar system. What kind of cosmic clockwork will you notice on your next visit to the shore?